Okay, in this video, we're going to discuss about the fourth unit is network topology. The other name of the network topology, we also call it as a graph theory. Now, before that, it's important to understand the terminologies in this network topology. First one is graph. The elements in the now here is the circuit elements. Okay, the circuit elements like the resistors, inductors, then capacitors, or the source extra, or which is the circuit branches, are replaced by the single lines with the circle or dots. Now this circle and dots are replacement for the nodes, the circuit, the nodes at both the ends. And then this configuration, now this way of configuration is called the graph. Okay, let me explain once again. Now you'll have the, okay, let's consider about the single circuit. You have the resistors uh, connected in parallel with the, okay, let's say voltage source. Resistor connected in parallel with the voltage source. Now that resistor and the voltage source are replaced by the two single lines. Or for the resistors, we are replacing it with one single line, and for the voltage again we are replaced with one single line. And then at the node where the resistor and the voltage source are connected together, we replace it with the circles or the simply dots. Then this configuration is called the graph. Now again we have different types of the graph: oriented graph or the unoriented graph, or we also call it as a directed graph or the undirected graph. Now again, if you take the same example, we have resistor connected in parallel with the voltage source. Now, when we replace that resistor and the uh, voltage source with the two single lines, and then that two single lines are connected with the dots, then if that line, single line, have a arrow or the direction shown, then we call it as a oriented graph, or we also call it as a directed graph. And then if that graph is without the direction, then we call it as a undirected or unoriented graph, which means it doesn't have any direction. Now, okay, in the again it's the same example, the resistor connected in parallel with the voltage source. In that, if you trace the arrow, direction of the arrow, then that line are called the path, which is simply the flow of the current from is flowing from the resistor and then through the voltage source, and then the circuit completes. Or the order sequence, see here, the ordered sequence of the branches traversing from one node to another is called the path. So these are the terminologies. Again, we have more terminologies. Okay, yeah, branch, what's mean by branch, you know that. What's mean by node, you know that. And then the representations. Okay, now this is not fixed. It depends upon it depend upon up to individual how to replace the nodes and the branches. Now these are just to give the name of the branch and the node. Now for me, I find it convenient, a small letter ABC or the one that numerical encircled may be used to represent the nodes, and the numerical simply 1 2 3 here is within the circle, right? I have numerical 1 to 3 for representing the branches. Now I will be using this representation, but it's not fixed. Okay, you can use anything. It's just the name of the nodes and the branch. And then the degree of node. Now when you say about the degree of node, it's the number of the elements or the number of the branches connected to that node. It's called the degree of the node. Now another terminology is now tree. The open set connecting all the nodes by branches, and the branches are called the trees. Now tree means it's the open set. Okay, to form the tree from the graph, you will not have the closed path. It's an open set connecting all the nodes by the branches. And then for the tree, the branches which are involved in the formation of tree is called the twig. So our normal language also we call that the as a twig, right? Same here. Now how to form a tree from the graph? It's the open set. Okay, there will be no closed circuit. It's the open set connecting all the nodes by branches, and then that branch, the circuit terminology is called the twigs. Okay, remember here, tree will have no closed path. Now, from the sentence itself, it's understood that it's open set. You will not have the closed path, and then the graph have n number of nodes, and then tree will have n minus 1 branches. So number of nodes is more than the number of branches. Remember that, because it is not the closed path. There can be many possible trees for the different given graph. Okay, now for the given graph we will have many number of trees, and then the links. Now those branches which are not included in forming tree. Now when you form the tree, we are just selecting a few branches, but that branches or that twigs are connecting all the nodes. Now from the graph, while forming the tree, you will left out some of the branches. Now that left out branches are called the links or the codes. Now when I explain through these sentences, it's quite difficult to understand. You will understand with the examples that we are going to solve. And if the links connects all the branch, okay, now when we left out all the branches which is not involved in formation of the tree, now if we connect that links, and then if that link connect all the nodes, then it forms a tree. Again, it is the other criteria for the formation of the tree is it should have no closed path and all the nodes should be connected. So that tree formed by the links is called the core-tree. Okay, remember here we have tree and then the core-tree. Core-tree is formed when if you connect the links and then that links connect all the nodes and there shouldn't be any closed path, then this is called the core-tree. Or the simply tree formed by the link is called the core-tree. Now here the example, if you replace this resistor with the graph topology, okay, here A, now exercise is draw the branches and the nodes for the network shown in the left. Now for this one, okay, these are the circuit branches that we have, the network branches that we have. For the A, we have simply the resistor, and for the B, we have resistor R plus L, and for the C, we have this parallel RC, and then D, R is connected in series with the voltage source. Now if we do the source transformation, you will have the current source connected in parallel with the resistor, and then again we have current source connected in series with the resistor, and then again we have RL connected in series, which is again if you combine these two parallel with the R connected in series with the inductor, and then it's connected, both are connected in parallel with the C. Now we have to draw the graph for those. Now we are going to solve for this one. Now this is the given network that we have branch R, and then to replace in the graph theory, simply this R is replaced with a single line, and then we have node with this circle here, small circle. So this is called the graph. And then again for this one here, we have R connected in series with the L. So for this one, we are replacing with again the single line here, and then for L also single line here. Or we can also replace it with R plus L, which is the impedance. We can find the impedance Z and then replace it with a single line. And then remember here, for node, I'm using, they have used the name node 1, node 2, and node 3, and then again for the branch 1 and branch 2. And then again for here also for R and C connected in parallel, we are replacing it with a single line. You can see they have drawn this line here and then it's connected with the small circle here. And or we can find the equivalent impedance for these two and then replace it with a single line. And then for the voltage, when the resistor is connected in series with the voltage source, or again we have the current here. Okay, first we are going to discuss it with the voltage. Now for the voltage, that the resistor connected in series with the voltage source, we have to think of the internal impedance of this voltage source. So for the voltage source, we are going to replace it with the single line short circuit diagram, which means for the R connected in series with the voltage source, we have to replace it with the single line diagram. Now this is the special case that we're taking with the current source and the voltage source. Now for the resistor or any impedance connected in series with the voltage source, we have to replace it with the single line. And similarly to the current source, when it is connected in series, when it's connected in parallel with the resistor or any other circuit elements, we can again replace it with the single line. Now for this one, we call it as an open circuit. Now internal impedance of this current, we take it as 0. So this one will become as open circuit. So we are simply replacing it with the current source as single line. And then another is here for now, when it is only the circuit elements, the branch, the resistor, capacitor, and the inductor, we can find the equivalent impedance here and then replace it with a single line node, or we can simply write branch 1, branch 2, and branch 3. Okay, now the second exercise is draw the graph for the network shown in the left. Okay, now this is the network that you have. Okay, for this one, let's draw it in the Microsoft Word. Okay, Microsoft Word. Now this is the one. Now we have understood that we can draw it with the shapes here. Now for the capacitor here, we can draw it with the single line here, and then okay, and then again for the R2 here, we can again draw it with the, okay, I think it's quite difficult to draw in this one. Okay, let's open with the band. Okay, let's use the snipping tool. I think it's easy to draw here. Now for the okay, first let's draw with the R2 with this line, and then here we have node. Okay, let's write node here, again node here, and then again for the L2 we have like this. Okay, this is still an anyway. It's quite difficult to draw in the laptop. And then from this node we have inductor L, and then here from this node to this node we have R. So you can draw directly like this. And then from this node to this node again we have R1. We can do it directly like this. And then from here to here it's connected with the capacitor C. So we can draw like this. Now this is called the graph, and then it's important to give the name of the branch. Okay, let's write node 1, node 2, node 3, and node 4. And then let's write branch A, B, C, D, E, and F. Now this is called the graph. And then in the first slide, when we study about the terminologies, we came across the directed or the oriented graph. Now this is called the unoriented graph. There's no directions given here. Now in order to find the direction, in order to call it as an oriented graph, we have to simply give the direction here. We have to simply give the direction like this. Okay, now after this, it becomes the directed graph. Previously, okay, if there are no arrow, okay, let's, okay, anyway, when there's no arrow, then it's called the undirected graph or unoriented graph. Now, after giving the arrow, it is called as a directed graph. And then now we have also come across the tree. What's meant by tree? Now tree, it says that the branches connecting all the nodes, but remember that there is no closed path. Now for this one, okay, now this is graph, right? From this graph, if you want to form the tree, if you want to form the tree, okay, let's erase this one, and then okay, let's also erase this one. Let's also erase this one. Now see, we have node 1, node 2, node 3 and node 4. They are connected, they are interconnected. Now this is called the tree. And then we have here, previously we had a branch F here, we have branch C here, we have branch A here. Now this A, C and F are called the links. Branch B, D and E are called twigs. Now tree we can also form using the branch A, branch A, E and again okay D. Now how to explain this one? Okay, now okay, let's also draw with another one. Okay, I think this will clear the confusions here. Now from this network, you have formed the graph, and then from the graph we have formed the tree. Now tree, in order to call it as a tree, all the nodes should be connected and there shouldn't be any closed path. So we are connecting node 1, node 2, node 3 and node 4, and then the branches which are connecting the nodes are called the twigs. That's the electric the network term for that in this part, like B, D and E are called the twigs. Now we have formed the tree, and then for this tree we haven't used the branch A, C and F. Now if we connect the branch A, C and F, and again it's connecting all the nodes. See, node 1 is also connected by branch A and F, then node 2 is connected by branch A and C, node 3 is also connected, okay, node okay 1, okay, node 2 is not connected. Anyway, node 1 is also involved in this in the formation of the tree. Node 1 is okay connected here, then node 2 is also connected, node 3 is also connected, node 4 is also connected. Now again there's no closed path. Now this is formed from the links. Now links are the branches which are not involved in this, in the formation of the tree. And then if we connect all the links together, and then if the link involves or connect all the nodes, then it forms the another tree, and that tree is called the co-tree, or the co-tree is the tree formed by the links. So this is called the co-tree. And then we have also came across the term path. Now if we trace this direction, now this is the path for this tree. See here, 1 to 2, 2 to 4, 4 to C. Now this is called the path. So that's it. And then in the next video we're going to discuss about the formation of the instant matrix.